Hello students. So today we will study classification and periodicity of elements theory part 2. So disclaimer, the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So what are the topics that are we going to cover today? First is ionization enthalpy, screening effect, electron gain enthalpy, electronegativity, valency, chemical reactivity, and then we will sum up with a summary. First is ionization enthalpy. So what is ionization enthalpy? So it is written here that it is energy required. So it's energy required when an electron is removed from the outermost orbit from an isolated gaseous atom, so as to convert it into gaseous cation. So it's very simple. So what do? We take an element, we convert it, if it is in gaseous phase, well and good. If it is not in gaseous phase, first we convert it into gaseous phase, and then what we do is we abstract an electron from an atom. Clear? And the energy that is required to do so is termed as your ionization enthalpy. And the resultant atom that we get is called as gaseous cation. So if we move from left to right in the period, then the ionization energy increases, and if we move from up to down, that is down the group, it decreases. But half-filled orbitals and full-filled orbitals are highly stable, thus have high ionization energy. So what happens is that, so as we move from left to right, okay, so suppose we are moving across the group sodium, magnesium, aluminum. So I'm taking that hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium. So it is the third period, right? So if you are moving in the along the third period, say sodium, magnesium, aluminum, silicon, phosphorus, chlorine, argon, then you will see that the ionization energy increases. What is the reason behind it? The reason behind it is that, see, the electrons are getting added to the outermost shell, and as they're getting added to the outermost shell, what will happen? This will result in increased electrostatic attraction, right? Increased electrostatic attraction for the same shell, and this will cause the shell to contract. Now as the shell will contract, what will happen? As the shell will contract, this will result in the smaller distance between the nucleus and the electron. So as a result of it, the electrostatic force of attraction will increase, and it will be difficult to remove the electron, resulting in higher ionization enthalpy. Clear? So, but there are some exceptions also. So for one exception you will see, if you are removing an electron from a half-filled or a full-filled orbital. So whenever you remove the electron from half-filled and full-filled orbital, we need comparatively high energy, and that results in a exception, right? But what is the reason behind it? So the reason behind it is the exchange energy. So we know it very well from the principles that we study in atomic structure, that half-filled and full-filled say electrons are more stable due to higher exchange energy. Now what are the factors that affect the ionization energy? First is atomic size. So as the atomic size decreases, the ionization energy increases. So we have seen it in a period. So we cross the period, the atomic size decreases and the ionization energy increases. Second is in the screening effect. So as the screening effect increases, the ionization energy decreases. Why is it so? Because screening effect is basically the block of, say, effective charge on the outermost electron. See what happens in an atom. We have an atom, we have the outer electrons, and there we have the inner electrons. Now the outer electrons experience comparatively, means from the effective nuclear charge that is experienced by that electron is reduced due to the inner electrons. So they act as a shield. Okay, they screen the charge or they screen the force, right? So due to that, the effective charge on the outer electron has decreased, and now they are easier to remove. Means the actual value and the ideal value are different. So ideally, if the force of attraction was completely there was no shielding or something like that, then the ionization energy would have a greater value. But due to this screening effect of the inner electron, the electrons can be removed easily. Next is nuclear charge. Very obvious, nuclear charge increases, therefore the force of attraction also increases, because this is completely based upon what? Electrostatic attractions. Now, since the charge has increased, the force of attraction is directly proportional to the product of charges, so the force has also increased. So we have to apply a greater force to remove the electron, therefore resulting in a higher ionization energy. Now, if I talk about the one element which has the highest ionization energy, so that is helium. There are two reasons behind it. The first reason is that it is having a complete octet, and at the same time it is having a completely filled orbiter. So this is the first thing, because they have a higher exchange energy, and in addition to that it has a complete octet, so it is very difficult to remove the electron. So this is the first reason. What is the second reason? The second reason is that they are the one which is having only one shell, means the outer electron is present in the first shell, which is closest as compared to any other shell in the atom. So from after 1 we have the 2 quantum number. So after 1s then we have the 2s, right? So to remove the electron from the 1s, it is very easy to do so. Sorry, it is very difficult to do so, because it is very close to the nucleus. Clear? Now next, ionization energy values of inert gases are exceptionally higher due to stable configuration and a smaller size, while alkali metal have lowest ionization energy due to their large size. Yeah, one more point. So cesium has the lowest ionization energy. What is the reason behind it? So the reason behind it is that, first of all, it lies in the bottom of the periodic table. It means that the outermost electron is getting added to the very outermost shell. Okay, then as compared to every element that is present, it is adding to the last shell almost. Okay. Second thing, after removal of one electron, cesium adopts a inert gas configuration, and as a result of that, what will happen? It will do so very easily, right? So these are the two factors that have resulted in a decreased value of ionization energy. Clear? Okay. Next. So we have seen that the ionization energy of inert gases are exceptionally higher. So inert gases have exceptionally higher ionization energy. Again, the two reasons are, the first of all, the complete octet, so it will repulse towards the removal of electron, because it already has a complete octet. Second, the complete octet will always have a filled orbital. Okay, so you have to remove the electron from a filled p orbital in case of inert gases. As a result of that, the ionization energy value will be higher. So the same thing is written, that to do the stable electronic configuration and a smaller size at the same time, you would say this also, because since the force of attraction is largest, so as we move across the period, the size goes on decreasing. So the last one has the smallest size. So as a result of that also, the ionization energy is higher. If we compare it with the alkali metal, they have the lowest ionization energy. And what is the reason behind it? Because when we start from the say first group of say first group, the period's first element has the largest size. Okay, so the distance is less, so electrostatic force of attraction on that last electron is less, so it is easier to remove the electron. Second thing, as we remove the electron from the alkali metal, we get a stable noble gas configuration, and therefore the atom prefers to go to that configuration and easily loses an electron. So the ionization energy is low. If we talk about the group 2 element, so group 2 element ionization energy is comparatively greater than the corresponding element of group 13 due to their full filled s orbital. What is the meaning of that? It means that the ionization energy of group 2 element is greater than the corresponding element of the group 13. So if you take the period like this, okay, if you take the same period and in the same period you remove two elements, first element from group 2 and 13th and next element from group 13, and now if you compare the ionization energy, then the ionization energy of first is always greater than the corresponding 13. Why is it so? Because it has a filled s orbital. So we know it very well that all alkaline earth metal have a general electronic configuration of ns2, right? And ns2 means completely filled s orbital, so it will have a higher ionization energy. Now, so we have heard this term shielding or screening. So the effective nuclear charge experienced by valence electron in an atom will be less than the actual charge on the nucleus. Okay, see here, means the experienced force will be less than the actual force due to the decrease of charge that is experienced by the electron, and it is due to the shielding or screening of the inner electrons or the intervening electrons, we can say. Next is screening effect. So what is the screening effect? So we can say it as shielding or screening effect, both are true. So it is the repulsive or repulsion of valence electron by the electron in the penultimate cell to reduce effective nuclear charge. So it is the inhibition which is offered by the inner electron, due to which the outer electron have to experience a less effective nuclear charge. So we can say that the Z effective means the actual Z effective for the electron is equals to the theoretical Z minus sigma, where Z is simply the atomic number and sigma is the shielding constant. So Z is the atomic number and sigma is the shielding constant. Now how do we calculate sigma? There is a rule for that. Very simple. So suppose we are removing the electron, or sorry, we are calculating the Z effective for the nth shell's electron. So what we will do is we'll simply multiply. Suppose there are 8 electrons in that shell, and you have to remove one electron. Then except that one electron, you will multiply 7 with 0.35 first of all, okay, plus 0.85 into n minus 1th shell. So whatever electrons are there in the n minus 1th shell, you will just multiply it by the 0.85. Suppose you are removing an electron from the third shell, okay, and the second shell electrons are 8. So what you will do, you will multiply 8 into 0.85 and then you will add it. Last is plus 1 into number of electrons in your shell. Now whatever electrons are there left, which are inner, which are not belonging to either n or n minus 1 shell, so we will multiply those with 1 and then we will sum these three. So we will take only the inner electrons. The outer electrons have no shielding effect, right? So this should be always clear in your mind. Next is electron gain enthalpy. What is electron gain enthalpy? So it is the energy released when an electron is added to an isolated gaseous atom to form the gaseous anion, right? So if your ionization enthalpy is the removal of electron from a gaseous atom, then your electron gain enthalpy is the addition of electron to the gaseous atom, and we get what? We get a gaseous anion. So if it is already existing in gaseous phase, well and good. If it is not, we have to convert it into gaseous phase first. Now electron gain enthalpy increases across the period while it decreases down the group. What is the reason? So when you move across the period, what will happen? The size will decrease. Okay. Now as a result of that, it will become more and more negative, or it will increase. So what is the meaning of that? So when the size is decreasing, you will get a closer approach to the nucleus. Okay, means if you are adding electron to suppose lithium, then lithium electron will be added to a farther point than the beryllium, right? Now what will be the result of that? The result of that will be that the electron will be easily added, because nucleus will have a greater effective force on that electron, and therefore it will result in more negative value or increase electron gain enthalpy. Means electron gain enthalpy magnitude is decreasing, right? But since it has a negative sign against it, therefore it is becoming more and more negative, or it is increasing in a way. So if you compare it with the down the group, so if you go down the group, then it decreases. Means the magnitude increases, but with the negative sign it decreases. And what is the reason of it? Because the size is increasing. Very obvious, right? Because the size is increasing and we are getting a less negative number. Okay, so that is decreasing down the group. Now, chlorine has the highest electron gain affinity. Why it has the highest gain affinity? So two reasons are there for that. Okay, two reasons are there for that. The first reason is that after attaining an electron, it gains a noble gas configuration. Second, of its small size compared to other halogen. Now you will say that fluorine is of the smallest size, it should be having the highest electron affinity. But see, the problem here is that fluorine has a very small size, so it has to overcome the repulsive force also. Due to that reason, the chlorine is comparatively much more suitable for the gaining of electron, and hence it has the highest electron affinity. But if you talk about the oxidizing power, so fluorine has the larger oxidizing power than chlorine. Now various factors are there on which electron gain enthalpy is dependent. First is atomic size. So as the atomic size decreases, the value of electron gain enthalpy increases. Okay. So as the size is decreasing, electron will be added easily and more negative value will be found, and therefore it decreases. So don't get confused about it, that why it is saying inverse. So it is taking the whole value along with the negative sign. Similarly, if nuclear charge is increasing, then electron gain enthalpy value is also increasing. Clear? Next is configuration. So half filled and full filled are, say, very stable. So electron gain enthalpy is comparatively very low, because it has a, why it is low? Because the half filled and full filled are very stable. Clear? Now fluorine and oxygen have small size, the same thing is there. So they have a high charge density, they have low gain electron gain enthalpy. Okay, they have a lower electron gain enthalpy. Clear? Okay. Last one. The electron gain enthalpy of group 2 and group 15 is low because of the stable half-filled configuration, but for group 18 it is positive because of complete shell. Okay, so this is low for what? 2 and 15, but it is positive for group 18. It is highly positive for group 18 because it has a complete configuration, right? So complete octet is much more valuable than your half-filled or full-filled case. Next is electronegativity. What is electronegativity? So electronegativity is basically the tendency of element to attract the shared pair of electron towards itself through the covalent bond. So suppose two elements are there, A and B, and there is a bond between them. They are bonded by a single bond. Now the bonded part will contain electron density. This electron density is being pulled by one of the element. So this pulling tendency of that element, okay, is called the electronegativity. So fluorine is more electronegative than most electronegative element, where cesium is the least, because fluorine has the smallest size and it gains noble gas configuration upon getting of electron. So electron gain enthalpy and electronegativity are somewhat connected, but when it comes to actual thermodynamics, then thus repulsion comes into play and fluorine has a decreased, you can say the fluorine loses to chlorine. But in electronegativity, since there are no thermodynamics involved and just the tendency to pull the shared pair of electron, so fluorine wins in this case. Well, cesium is the least because cesium has no competition. It is easily available to lose these electrons. Okay, and the size is larger, so it does so very easily. Next is decreasing order of electronegativity. So if you talk about the decreasing order of electronegativity, so how does it decrease? So it decrease in this way. Fluorine, oxygen, chlorine and nitrogen have similar, then bromine, sulfur, carbon, iodine and then hydrogen. Okay. If you talk about the period, again moving from left to right, the size decreases, therefore the electronegativity increases, because now electrons are much more closer to the nucleus, they are experiencing greater force. If you move down the group, the electronegativity decreases because the size is increasing. So electrons are much more less attracted toward the nucleus. If let us talk about the measurement of electronegativity. So there are some important scale to measure the electronegativity. Those are Pauling scale first of all. So suppose the difference in the electronegativity of two elements A and B is given by chi A minus chi B is equals to, where chi A is the electronegativity of A and chi B is the electronegativity of B. So it is, the difference is given by 0.102 root delta, and this is in delta is in kilojoule per mole. If you talk about kilocalorie, then it is chi A minus chi B 0.208 root under delta, and here your delta is in kilocalorie per mole. What is delta here? So delta is actual bond energy. Okay, so to break two atoms, whatever is the energy required, it is called the actual bond energy minus energy of 100% covalent bond. So if it was a 100% covalent bond, then what would have been the energy? That energy is subtracted. So delta is that. Okay, so delta can be calculated how? It is energy required to break A and B bond minus root under energy required to break AA bond multiplied by energy required to break BB bond. Here, same thing written. AB is the dissociation energy of EAB is the dissociation energy of AB, which is represented by kilocalorie per mole or can be kilojoule per mole. Similarly, AA is the dissociation enthalpy of AA, and EBB is the dissociation enthalpy of BB bond. Next is Mulliken's scale. What is Mulliken's scale? So it is represented by simple formula ionization enthalpy plus electron affinity divided by 2. So Mulliken's scale, if you talk about, it is 2.8 times greater than the Pauling scale. So whatever value you will get for Pauling scale, Mulliken scale will have a 2.8 times greater value of negativity for the same. So if you want to write the Pauling scale in terms of your Mulliken's scale, then simply what you will do, divide it by 5.7 in place of 2. Or you can write it in this way also, that your Mulliken scale and Pauling scale are say related in this way. What is the unit of electronegativity? It is simply EV. And for noble gas, this is taken as 0. Why? Because they have no tendency to attract electrons as they have a complete octet. One thing is to note here that sp hybridized carbon is more electronegative than sp2 because it has a greater S character, which is 33.33. For sp it is 50% S character, so it has more electronegativity. sp2 has a greater lesser S character than your sp3. So sp carbon is more electronegative than sp2, and sp2 carbon is more electronegative than the sp3. Clear? Why it is so? Because of the greater S character. Let us talk about the valency. So the valency of an element is related to the electronic configuration of its atom. So it depends completely upon the electronic configuration of the atom and is mainly talking about the valence shell, electrons present in the valence shell. So if you move in a period, the valency of the element with respect to hydrogen increases from 1 to 4 up to group 14th group and then decreases. For example, NaH, CH2, AlH3, SiH, PH3, H2S, and HCl. Okay. So next thing is valency of the element with respect to oxygen increases from 1 to 7 along a period. So if you move down the group, then your valency of the element increases with respect to oxygen. So you can see valency here, it is increasing. It is +1, then +2, +3, +4. Okay, so it is going on increasing. +3 and +7. Now all elements in a group have same valency. If we talk about the same group, they all have the same valency and they have the same number of electrons in the outer shell. So this is the thing that is to be noticed. So if you move across a period, then the valency will increase. If you move down the group, the valency will remain constant. Okay. Now p block elements show variable valency on account of the inert pair effect. So you will see this thing that they have the inert pair effect, and due to that reason they have the variable valency. Now The term oxidation state is also being used for covalence, so which indicate the actual charge on atom in that particular molecule. It follows the same trend or group as the valence. So it is almost same to oxidation state and follows the same trend also. Now note this, tin has maximum number of isotopes and osmium has the highest oxidation state of +8. Transition and inner transition metals show variable valence, that is 1, 2, 3, as they use electrons from outer as well as penultimate or inner penultimate shell. What is the meaning of this? The meaning of this is that the transition element electrons can be removed from the, suppose sixth shell is a last shell, then it can be removed from the fifth shell also. Due to that reason, it can show variable oxidation state. If you talk about the chemical reactivity, then the reactivity of metal increases with decrease in ionization energy, because as the ionization energy decreases, it is easier to move the electron and easier to form the bond. And it also decreases. So if the ionization energy decreases, it is easier to remove the electron, and if it is increasing, it is difficult to remove the electron. Now, as the electronegativity also decreases, electron can be easily removed, and hence reactivity increases. And same goes for the atomic radii, because if atomic radii is small, then then it will also increase it. Okay. And since electropositive is so if atomic radii is small, then it is difficult to remove the electron and reactivity decreases. And similar, if electronegativity decrease can result in increase of reactivity, then electropositivity increase can increase the reactivity. Okay. Reactivity of non-metal increases with increase in electronegativity, electron gain enthalpy, and increase in atomic radii. So it is said that, so if you are increasing the electronegativity and electron gain enthalpy, its reactivity increases. So it is opposite of the metal, and decreases with atomic size, because now they can take up electron easily. Therefore, if your size increases, it will face difficulty to take the electron. So if you decrease the size, it can easily take the electron because of the smaller distance between the incoming electron and the nucleus. On moving down the group, reactivity of metal increases, while for a metal it decreases. So if you move down the group to cesium, it can easily donate electrons, so it is highly reactive. Whereas you move from left to right in a period, then the non-metal reactivity decreases. So you can see for noble gases, it has the least reactivity. Now reactivity of metal decreases while reactivity of non-metal decreases across the period. Okay, so this was about group. Okay, sorry for that. So this is about period. So I have just talked about period. If you talk about the group, then if you move down a group, say we are moving from up to down, then the metal reactivity increases because of the ease to remove the electron. Okay, while for non-metal it decreases if you move up to down. But if you talk about the metal, then the reactivity of metal decreases while reactivity of non-metal increases across the period. If you talk about the reducing character of the element, then it increases down the group, because it can easily donate electron and get oxidized easily, and hence reduce the other easily. The oxidizing character of the element decreases down the group. Why? Because it can lose easily electron, so it is getting oxidized itself and reducing other one. Okay. Now alkali metal are most reactive, strongest oxidizing agent, and have lowest ionization enthalpy. Well, halogens are the most reactive, strongest oxidizing agent. Very obvious, because alkali metal, when it loses electron, it easily gets the electronic configuration, and is oxidizes easily and reduces the other element easily. Where in case of the noble gas or halogen, I would say specifically, they are more reactive because it easily accepts electron, and therefore it has a greater oxidizing character. Now metal forms basic oxides, while non-metal forms acidic oxide. Basic strength of oxides or hydroxide down the group, it increases down the group, while acidic nature of the oxide increases along a period. Almost all metallic oxides are basic, but except your ZnO and Al2O3, which are amphoteric. Amphoteric means they can act both as acid and both as a acid and a base. Now if you talk about non-metal, then CO, N2O and NO2 NO are acidic. Okay, while Cl2O7 is the most acidic oxide. Okay, so what it is been said here, that these are not acidic. Sorry, this is not acidic. These are neutral, but all non-metallic oxides are acidic except these three. But Cl2O7 is the most acidic oxide. So we summarize this. So ionic radii, we have seen it earlier. It is the measurement of the atom's ion in the crystal lattice. Ionization enthalpy, it is the energy required to remove the electron from a gaseous atom. Screening effect is the shield, or the, you can say, the barrier through which the outer electron net effective charge is decreased. Electron gain enthalpy is what? It is the addition of electron to a gaseous atom. Electronegativity is a tendency to attract the shared pair of electron towards itself. Valency is what? It is the combining capacity of element, and often defined as a number of hydrogen atom it can combine with. Chemical reactivity, so it is referring to the tendency of substance to undergo chemical changes. Thank you. This was for today.